Good morning, everyone. Hope you're doing well. Thank you for joining for our final series, where we're going to be looking at OpenShift. It's presented some technical challenges, I think it's fair to say, and AC will go into those as we go. But like you've done on the previous webinars, please ask as many questions as you can. We want it to be as interactive as possible. And yeah, so I'll hand over to AC now to do the deep dive.
Hello, everyone. So as Tom said, it's time for OpenShift. We're going to be focusing on Red Hat OpenShift Virtualization Engine, or what's abbreviated to OVE. It's the cut down version of the bigger product. What's in our lab is the bigger product. How it works is they charge you depending on what you do within the platform, kind of thing. I'll show that there's a cloud platform that monitors the usage. Depending on what you do within the platform means you sort of get charged differently. So we're going to be looking at how you license it and the various additions in addition to the virtualization. I'll show you what you get if you pay a little bit more. Looking at the management plane. There's a very extensive API and a very extensive command line interface, which I'll jump in and out of over the course of the webinar, but there is a very useful and intuitive web interface, which I'll go through in detail. High availability, so similar to the prior webinars, we'll be looking at quorum models, fencing, these kind of things. What happens when you have a hardware failure or something goes wrong in the platform. Resource scheduling, so affinity, anti-affinity, how the system places virtual machines when they turn on, so to utilize the best resources in the cluster, that kind of thing. Live migration of virtual machines, so moving a VM between nodes. Live migration of storage, had some challenges with that. The feature was in preview until fairly recently, and then it came out of preview and then went back into preview and then came out of preview again. So they're working on it. I'm on 4.20, which is the latest version, and it is supported, and it's no longer in preview. Disaster recovery. So for that, there are multiple options. There's a baked in option within the product. There's a Red Hat product. We're going to show you a NetApp product, which is very similar, but has particular use cases for NetApp customers. What we're going to do is take virtual machines running in the first primary location, assume there's a failure, and then fail them over to the secondary location using SnapMirror and what's called Trident Protect. We can get into that. And then show you a demo of how to get the VMs out of VMware and put them into OpenShift. So our lab, it's actually changed. I didn't get time to update this slide. So in the primary location, we have five blades, not 3. So the 3 on that slide there are control plane and master nodes. I can get into that when we get onto the management thing. I'll explain what all that means. Essentially, it's hosting all the control plane and management plane components for the platform. There's an additional 2 what's called worker nodes where the actual virtual machines run. There's a separation between management and the data or customer plane, essentially. So we have 5 nodes in the lab. It's kind of recommended to do that. There's a lot of stuff that runs on those management nodes, control plane nodes. And although you can co-host virtual machines, it can cause some challenges. So we've got 5. In the secondary location, we've just got 1 single nodes. That's the minimum commit. Everything's on there, so that's all of the roles within OpenShift are running on that single node. In the background, there's a NetApp, same NetApp we had for the other webinars. It's running NFS. It's orchestrated through a thing called Trident. So depending on what storage vendor you're with, they will very likely have a storage driver. It's called CSI, Container Storage Interface, and that essentially runs some software in a container inside OpenShift, which talks to the APIs of your storage array and does stuff like provision storage, etc. So we're using the NetApp Trident CSI because we have a NetApp array. And then backup target, because we have a NetApp array, it's multi-protocol, so we're running S3 buckets on the same NetApp, and we are mirroring both the NFS through traditional SnapMirror. If you're on another array, whatever vendor technology to do the replication of the array, and then S3 is being also mirrored through the SnapMirror as well. So you've got this kind of two mirrors going on. The other thing to note is that the blue box at the top. So there are probably about 6 or 7 pathways to install OpenShift. They're slowly condensing down into quite simple ways to do it. So they've created a way to bootstrap the cluster through the cloud. So there's a cloud portal where you create the cluster and you download an ISO file, you boot the ISO file, and it will instantiate the cluster, and everything will start working. It makes it a lot easier. There are user provisioned ways where you do it all manually, and we've done it in the lab and it's fine, but the cloud provisioning thing is much easier. We tick the box for what's called bare metal, which installs a thing called Metal Load Balancer, which basically runs, if you know Linux at all, it runs Keep Alive, which is a VRRP software component. The good thing about that is that the access into the API and the web console goes through this Keep Alive. It's a pod, it's a container running as what's called a daemon set. It runs on all the nodes, but it's active, passive, passive. So if you've got 3 control plane nodes, it's only active on 1. So that's the downside, is that you don't get that throughput of all the nodes. But the good thing is it's just really easy, and it just does it out of the box, bang, and you do not need an external load balancer. So if you do a non-Metal LB deployment, you do need an external load balancer. Obviously, if that was virtual and you were running the thing inside the thing, if you're trying to run it inside OpenShift virtualization, that's not going to work too well, because you need the load balancer. It's chicken and egg scenario. So you probably want physical load balancers or load balancers somewhere else. So Metal LB is a reasonable solution which gets you around that problem. It allows the clusters to start and to be load balanced without needing a physical load balancer. There are dense and rich concepts as I go through this webinar, and probably fair to say, if you've never touched Kubernetes in your life, you don't know what it is. There's going to be a lot of concepts here that might not make sense, and you could keep watching this webinar and pick up the concepts and go do some reading and stuff. Please ask whatever questions you want to ask. It's a dense subject, so yeah, just bear with it, and I will try my best to unpack it slowly. So licensing wise, there are 4 broad flavors. The left-hand side is the one that you saw pricing for on the first webinar. So that is OVE. So essentially, you can run virtual machines on bare metal. The system does run containers, but those containers are system containers or infra containers that are embedded in the license and are permitted to run. But if you try to run your own container, then that is not permitted within that license. So it's limited to virtual machines only. The next one is OpenShift Kubernetes Engine, which is like the step up. So it's basically almost the same thing, but it allows you to run containers as well. And you can see there it says Red Hat Guest, virtual OpenShift subscriptions included. It's interesting that it's on there, because I know OpenShift Container Plus, the last one, you get unlimited Red Hat Enterprise Linux licenses baked into it. It's like having a site license, and you can just run as many as you like, virtual machines and containers. So I'm not quite sure why that's on that slide there, because it only comes in the last one. The next one up is Container Platform. So that's when you start hearing acronyms like OCP, OpenShift Container, or OpenShift Container Plus. That's where you get the full stack of virtual machines and containers, but you also get CI/CD and pipelines, and they use a thing called Argo CD, which is a CI/CD tool to basically create a Git repo with code in it, which the OpenShift cluster pulls and deploys the environment. So if you're in a kind of DevOpsy type world and you want to do continuous integration and continuous development, and you want to have everything driven and written in code and deployed like you would in a cloud, 100% it does that. It's totally designed to do that. You would need the bigger product to do that, because well, you could technically run. Let's not go there. There are ways around that, and you can have a conversation with us separately because it might confuse everybody. But yeah, basically the CI/CD stuff with Argo is in container platform, and then the plus version gives you, in addition to everything else, it gives you Ceph, so it'll give you hyper-converged, and it gives you multiple a multi-cluster management plane. So you can have like multiple clusters all around the world in different regions, in clouds, in public clouds, in private clouds, and you can wrap them all into one console. You can back up and restore between those clusters, that kind of thing. There's some additional security stuff, which is baked into it. And you get you get Red Hat Key, so a container registry. Doesn't mean you couldn't run your own container registry, maybe Harbor. There's lots of container registries out there, or use as your DevOps service or GitHub or whatever. It's just it comes with its own private container platform. I would say broadly speaking, OpenShift is what's called like an opinionated deployment of Kubernetes. So Red Hat have cherry picked the best of the best out there and wrapped it in a enterprise support model, basically. So a lot of the stuff you see you can get open sourced, but Red Hat are wrapping their arms around you and giving you full enterprise support. I have log tickets with premium support with Red Hat 4, and they are very, very good at getting quickly to the issue. They'll even do root cause analysis for you, which a lot of support companies won't. So they're very good. So with OVE, the stuff we're going to really talk about today in terms of just virtualization, if you wanted to run containers on that platform, it is possible. What you'd have to do is run a separate, in quotes, hosted control plane, so a virtual machine based OpenShift cluster inside OVE, which you can then run containers within virtual machines. That's called hosted control planes, and it's doable. You'd have to license the hosted control plane with VM core licensing. So you could work out how many containers you need, and you can buy a minimum footprint of virtual cores for OCP, for example, and run that as a hosted control plane in OVE. Might sound confusing, but it's a way to get containers within OVE. If you did have the other guys like OpenShift, Kubernetes Engine, all the other three options, you can run the containers and the virtual machines together on bare metal. So there's a difference there. One's in VMs, one's in bare metal. You could also run them in virtual machines on the other ones, but I don't know why you would. You've got bare metal. From a licensing point of view, as I mentioned before, in our lab we've got three nodes as the control plane. Those you don't license them, so you have to buy hardware. Reasonable hardware, Gen 10s, DL360 Gen 10s, for example, would work. They're certified for Red Hat 10. They're certified for OpenShift. And you can separate out even further. So you could have, I'll go to the next slide. So you could have control plane nodes on physical bare metal. You could have the compute nodes that run your grunt, your virtual machines, on bare metal. And then you can, if you had a very large cluster, you could also separate out what's called infrastructure. So metrics, it says on the screen, there's stuff in blue there. So metrics, logging, monitoring, the ingress, so how traffic comes into the environment, container registry, that kind of stuff you can place on other bare metal nodes. So you can have this kind of tiered approach where you have dedicated control plane, dedicated infra nodes, and then worker nodes. The only thing you'd license is the worker nodes. So all of this other stuff, you're just paying for hardware. You're not paying any support costs or licensing costs. It's just worth knowing that. Also, really good thing is if you have multiple sites and you're doing anything but hot DR, so you're doing like cold DR, which is what we'll be doing in the demo, where you've got stuff prepared, you've got infrastructure built, but it's not running the actual workloads. It's kind of ready to run them. You don't pay for the DR site, so you don't have to license it at all. You can transfer the license from that site to that site, from production to DR at no extra license cost. That's really good. And another thing they've done recently is they've eradicated or removed the core count limit. So if you have a thread ripper, like let's say you got 4 thread rippers in a box, you can license them all with one node license for OCP. So that's actually quite a win. You could build much bigger boxes, get much more stuff within them. Okay, you create larger failure domains, but arguably it'd be cheaper. So that's some stuff that's changed fairly recently. If you need that information on that, we're a Simplifier CCSP partners, so we can get all that information to you. So I think it's probably time to move on to management, and I will jump off this slide and show you management. Bear with me. Bring this over. So here is the OpenShift console. So home page. There's a home page. It shows you lots of information. You can see I've got some issues with some of my system memory on some of my nodes. So it has this really cool thing where you can go and click down here. So all of these metrics down the bottom are coming from a Prometheus Grafana stack. So if I click on them, I can see over time, I can see metrics. I think I clicked on memory, so I can see memory over time. I can click and zoom in, I can zoom out, I can stack them and unstack them. Ultimately, what it's doing is it's using PromQL, which is a Prometheus structured language. If you ever used Azure Monitor, you'll be familiar probably with KQL, which is the Microsoft language. So a similar kind of thing. You can write your own PromQL queries. You don't have to. There's dashboards and there's pre-baked ones. But yeah, it's all built around a structured Prometheus language. So the next thing down on the list, projects. So concept of projects. Projects are essentially, in Kubernetes, they're called namespaces. In OpenShift, they're called projects. Think of them as tenancies. They're, in quotes, a unit of collaboration and isolation. But essentially, it's tenancy where you can apply security, RBAC, roles, gain access through permissions. You can deploy resources like containers and virtual machines. You can apply quotas and say this tenant or this project can only have, or this team, depends on how you want to structure it, can only have this much CPU and this much memory. So it's a little bit like DRS in that sense. Yeah, there's a lot you can do within each project, but ultimately they're carving outs of the underlying infrastructure for whatever purpose you want them to be. In a multi-tenant platform like our private cloud environment, we have a project with the design is that each project is a tenant, is a customer, and then we segment that out and separate it. There is a concept of an ecosystem or a software catalog. So basically what this is a pre-qualified marketplace, let's call it the cloud marketplace, but it's the Red Hat marketplace. And there are loads of things in here. So these are all ways to extend the functionality and feature set of OpenShift. So if I type Cisco, you can see I can integrate OpenShift into ACI. I can integrate it into UCS. If I type NetApp, you can see I can integrate it into a NetApp, etc., etc., etc. All the major vendors play this game. You know, whatever the vendor is, you can do it.
We've sorry to interject. We've got a question, mate, if that's okay.
Yeah, please.
So can you oversubscribe the projects, i.e. you have 10 nodes, but you give project 1 10 nodes and project 2 5 nodes?
So you don't subscribe nodes to projects, you'd subscribe CPU and memory usually. So if you arbitrarily set, like, let's say you have 10 projects and each of those 10 in aggregate was way above the resource, yeah, you could technically do that. Yeah, you'd have to be careful as to how you design your resources. Kind of get onto that in a minute, I guess. So if a node starts to get constrained on resource, it starts to do things like potentially killing virtual machines or moving them in order for the system to survive. It's one of the main reasons you do not want to, well, it's not recommended to run your virtual machines on the control planes because they're quite busy anyway. And you don't want the control plane to be hurt by a virtual machine going crazy. So having them separated on different nodes protects that. Yeah, so it's not so that the resources are memory and CPU. There are disk I/O and stuff like that, but yeah, more for CPU and memory. Yeah, hopefully that makes sense. You just got to be careful how you design it, essentially. You can also say, rather than disk and memory, you can say the user can only create one virtual machine or one of these things like a disk, or you can do it on item count as well as CPU and memory. So that's the software catalog. You'll notice here there are little badges, so certified and community. The certified ones obviously are the production ready ones. They're downstream from the source, so they're slightly lagged behind in this case Dell. They're slightly lagged behind because they have to go through a qualification process and be fully certified, but not too far behind, but slightly lagged. Same for all of them. If I was to look at this, go back to my NetApp one, you'll see there's a tag saying certified, there's a tag saying community, and there's a tag saying Helm chart. Interesting. So what's Helm? Helm is a package manager for Kubernetes, and it allows you to deploy things like, in that example, Trident Protect, but there are millions of things you can deploy with Helm. If you plug a repo into OpenShift, then those become available in the software catalog, but they're not necessarily certified by Red Hat at that point. But some stuff, like my NFS driver, so I can attach NFS storage without Trident. Trident, you just do it through Trident. That's a Helm chart. So basically, there's a whole repo of millions of things on the internet for Kubernetes, which you can attach into here and deploy them through the software catalog. It will then manage them and update them, which is quite nice. Workloads. So Kubernetes works with a thing called CRDs, custom resource definitions. They are, let's call them API objects. So there are tons and tons and tons and tons and tons of API objects, lots of things which are defined within the database. The workload section picks some of the most useful or relevant ones, like pods. Pods are, I go all projects. Pods are buckets for containers. A pod can contain many containers, like that one there, that alert manager, which is part of the monitoring stack, has 6 containers in it. Deployments orchestrate and keep pods running. So if I deleted this pod here, the deployment would restart it and restart 6 pods. I don't need to go. We're not trying to do a Kubernetes training course. Happy to do that at some point, but yeah, not doing that today. But basically, these are objects that are useful, secrets to store passwords and things like that. Configs maps are a really interesting use case. They allow you to mount, like, for example, like if you had an Nginx web server, let's say you were hosting a website, you could change the content of the structure of the file system by mounting a config map into the container, and it would change the actual mounted file system. So you can then change the config map, which then changes the file system. So interesting use of config maps. They're used extensively within the world of containers, and you can also attach them to virtual machines as well. Lots of things, cron jobs, yeah, blah, 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 blah. All these are basically all different things within Kubernetes. Virtualization I'll come back to in a bit. That's obviously the thing we're really interested in. Networking, interesting. So networking from a virtual machine point of view, I'm going to bring back a slide. I'll tell you what, I took a while to get this coherent, and I'm hoping this is not going to confuse you. So there are 3 principal ways to attach networking to virtual machines. There is what's called a secondary local net, which is in a sense a traditional virtual machine VLAN. So you're probably going to want to use that because that just brings your VMs in as they maybe are today on your VMware environment. If you have NSX, it's a little bit different because NSX will be doing microseg and they'll be on overlay networks. Anyway, IP allocation is customer dependent. The reason why is because it's up to you what you do. You might do DHCP, you might static IP. Microsegmentation is partial because when you throw microsegmentation policies at a project to constrain what virtual machines can talk to each other or what containers can talk to each other, like you might, for example, say this project can only talk to itself but can't talk to other projects and vice versa. So you're kind of constraining the networking within that project. That only works with the pod network, not the VLAN. So I can show you that in detail. But essentially, when you bridge VLANs, the VLAN IP for the actual virtual machine, the real IP of the virtual machine, if you ping that from outside or inside the cluster between things which are supposed to be microseg through a network policy, it bypasses the network policy. The only way that it will work is if you resolve the name of the virtual machine using the clustered DNS service, which resolves it to a slightly different address, which then constrains it. So if you had a microservices application, like a big one with lots of, let's say you had 100 containers and then you had this kind of database virtual machine, the developers are probably going to talk to that database via the internal name within Kubernetes, which will work with microseg. But if you're talking about a VM which you're going to join to Active Directory, and Active Directory is another virtual machine like an AD controller running in a VLAN, the communication between those two systems is not going to be microsegged. So it's kind of partial. Pod networking is the default network. It is technically a Geneve overlay network like it is with NSX. So when traffic flows from node 1 to node 2 or node 2 to node 3, it gets encapsulated and de-encapsulated just like NSX does. It has its own IPAM system, so it will allocate an IP address. It weirdly gives the virtual machine it gives the virtual machine the same IP. Every single virtual machine in the environment gets the same IP address, and that routes through another pod behind it. So what's weird about the pod networking is if you had I'm sure you can picture this, you have a virtual machine, which is a Windows machine, you join to the domain, and the domain controller is running inside. Let's say it's running outside still on a physical machine, just to make it easy to understand. When you do the IP DNS registration, which Windows will do by default, it's going to register that it's a 10 address, which isn't the address you want it to register. So all of the DNS entries in AD are going to have this random address. And things are going to be interesting because when you're talking within the AD world, DNS resolution, it ain't going to work. So I don't think pod networking is a particularly useful use case for virtual machines. It's only really relevant if you want to do microservices only and you're not doing external services like Active Directory. Because if you resolve it from the internal address from Kubernetes point of view, like I say, from a microservices platform, then it is going to resolve to the correct address. And then you have this other concept of a layer 2 overlay, which again is another Geneve network that spans the entire cluster. Your cluster could span multiple geographies. We'll get into that in a minute. That doesn't have any way to route in or out. It's purely for an interconnecting private network. So within VCF 9, you have this concept of VPC private networks or private subnets. Those guys, you can't, it's sort of like just an internal connection. So if you think of like the old days of like Exchange server where you had inter mailbox replication over a dedicated network, or SQL if you wanted SQL to replicate over a dedicated network, that's that use case essentially. The main thing is to know is that the overlay network spans the cluster. So you don't actually do anything. You just create it and it just creates it. And then it automatically Genev encaps and de-encaps across the whole network. You don't, it's like 3 clicks and it's done. That's the use case. I can show some of that. When I get into the VMs, I'll show you some of the networking for real, because a lot of that is very heady concepts. So storage wise, if I go down storage, so everything is driven through what are called storage classes, and storage classes ultimately link to a provisioner. And you can see here I have Trident CSI. If you know NetApp, I'm just going to pull up a file, which is what this file here is, what that is talking to. So that provisioner is talking to this, and this is talking to our NetApp. You can see here I have a bunch of IP addresses. This is a LIF, the ultimate destination of where it mounts the NFS. Other bits and pieces. These are like similar options you'd see in a NetApp, right? So export policy, tiering policy, da-da-da-da-da, how you want to name it. So you create a backend config within Trident and you link it to a storage class, and then it goes and talks to the API of the NetApp and starts provisioning storage ultimately. So you end up with these persistent volume claims. Now, each of these persistent volume claims is ultimately, and I can show you so you can make sense of it. Is ultimately one of these. So each PVC becomes its own volume on the NetApp. So you end up with lots of volumes on the NetApp. NetApp has limits on how many volumes, as you probably well know from Harvey Universe. I'm doing what's called ONTAP NAS as a storage driver. You can do SAN, you can do flex groups, you can do what's called NAS economy, where it combines more volumes into more PVCs into one volume to create more efficiency on the amount of flex files it creates. There's a stupid amount of options. This Trident configuration, or the Trident system, or the Trident software itself, goes as far as to support multi-site metro clusters and everything. So pretty much all of the feature set within the world of NetApp is baked into Trident, and then you can get Kubernetes to interact with whatever you happen to have from a NetApp point of view. If you're not NetApp and you're some other storage vendor, then you will no doubt, and I know of a few without mentioning names, that have CSI drivers, and they're very capable. Essentially, everyone's writing these things and everyone's wanting OpenShift to interact with the arrays. So that's how they do it. They do it through, there's a piece of software running inside the Kubernetes platform or the OpenShift platform, which is like a middleware between when I create a PVC and the NetApp, and it will go and talk to the API and provision the volume. This concept of builds, which is the bigger product. This is more for building container images. If you wanted to, like you had a Docker file and you wanted to actually build it, you can build it within the system as its own way to do that. It uses shipwrite in the background. It's got GitOps and stuff, so you can do, I think I mentioned it before, it uses Argo CD, and it uses Tecton for pipelines. So all of that side of the development of containers is baked into the bigger product. The observation stuff, it does have I think I've mentioned it before, but it does have dashboards. So rather than writing your own Prometheus query language and getting the book out and trying to work that out, you can just go and pick out stats. Because it's all coming from a Prometheus Grafana stack, it's incredibly detailed. And there's an insane amount of information you can get here. You can trap these, you can set up alarms and things if things go beyond certain thresholds. All the normal things you'd expect to be able to do, you can do. Yeah, there's a whole bunch of nice stats which you can look at in here, but obviously you don't want to be looking all day. You want it to be sending ITSM service tickets into whatever you use, which you can totally do. So under compute is where we've got more physical stuff. So nodes. So you can see here I've got 3 control plane nodes, a control plane master, and I've got 2 workers, which I mentioned before. The interesting thing about this is that if I go into bare metal hosts, these 3 were built through the bare metal. I think I mentioned it before. They've got metal LB on them. I don't have power management because these are B200 or B220. I want to say B220. B220 UCS blades. They're not supported for the DRAC, ILO, CIMC, whatever you want to call it, the out-of-band connection. It actually uses a thing called Redfish to connect to the IPMI. If I did have that, let's say these were C series or they were HPDL 360s or whatever, then the system actually has inside Kubernetes, inside these objects, is literally all of the configuration for the host. So if I went and looked at the master and went to machine configs, these are all things like, for example, SSH. So this is an SSH configuration for the node. This is the time sync configuration. This is the kubelet. Kubelet is the agent for Kubernetes, which talks to the control plane. Lots of stuff. So all of the configuration of the actual host is stored in Kubernetes. So when I make a change, I don't log into the host physically and make the change. I log into the control panel, log into here, or I log in via the CLI, or I orchestrate it through Argo and I write it in code and it pulls the code from the Git repo. All of those methods are perfectly valid. The point is it's orchestrated through here. So I change it here, and this is the source of truth. This then orchestrates the change on the node. That means that if I lost the node or the node had a problem, if I had the IPMI out of band connected, it can actually self-heal. It can actually take that node out, completely destroy it, rebuild it over iPXE and bring it back in healthy. And it can do that automatically. So it has this kind of self-healing mechanism. Also, because it has that capability, it can also auto scale and auto shrink. So it can dynamically change the number of nodes depending on load. And it can do that automatically. You have to set up the provisioning network and all that kind of stuff it uses. You need to have a DHCP server at layer 2 inside a provision network. But ultimately, when you set that up, you can suddenly add 10 more nodes. So you've got more of that kind of elasticy type cloudy world where things can grow and shrink depending on need. User management, fairly straightforward. It's very, very comprehensive. So the base principle is you've got roles. So roles allow you to do things. So I look at like admin. You've got this thing called verbs like create, update, patch, delete. And the API group is which object, which bit in Kubernetes you want to edit. It's insane. You can create a very, 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 very specific thing to allow person X to only do one very tightly grained thing. Once you've got the role, you create a user or a group. The users and groups can come from different sources. I'll show you that in a minute. OADC, LDAP, whatever you want. And then you bind them. So you create a role binding. I think if I type sit admins. So I created a role binding called sit admins, which gives us cluster admins, and that's bound to this group. So that gives us the role, essentially. It's very, very, very good and granular, essentially, once you get to grips with it. Under administration is where you can see the cluster updating last night, which is a bit crazy before a webinar. I upgraded it to the latest for 2014. You can change the channels. There are stable, fast channels, candidate channels, things that are slightly ahead, but essentially you want the stable channel for production. And you can just literally edit it and change the version, and it will go and upgrade. It does that completely dynamically. You do not need to touch it. It will cycle. It will move all the virtual machines away and onto different nodes, and cycle through the control plane, cycle through everything, and just upgrade it. I was actually preparing for the lab whilst doing the upgrade, and I didn't have. Although the web interface here dropped and rejoined when the pod restarted, I just carried on working. So
I've got another question, mate.
Yep.
What are the roles with the GUI IDs?
What are the roles with the GUI IDs? So where was I? I was in OpenShift Marketplace. I don't know. Let's have a look. That's what they look like in raw format. So it looks like that. Whatever that is, can do create, get, update for config maps. It looks like part of the ecosystem to me. Allowing it to change config maps. I don't know what's bound to it. You can have a look at it, but yeah, they baked it. I haven't created them. They've been created by the system. So in terms of auth, OAuth is here. You can add all of these identity providers. So in our lab, I've added Entra, which is OpenID, to a enterprise app within Entra. I've got HT password, which is using the HT password standard Linux tool. You can create a hashed username password and then upload that. And that's actually how I'm authenticated right now, is with HT password. It's just static usernames and password. You really want to use it in production. It's just a backdoor to get in easily, because SAML and 2FA and my phone and everything, it's not great for the lab. You can see there's lots of different options there. So capable thing. So probably the virtualization console is the thing. So you do have this view mode, which all that does is constrain what you see here. So if I go virtualization, all of a sudden I only see stuff that's related to virtualization. If you go developer, I only see stuff that's related to a developer. Fair enough. Yeah, it's doing nothing more than removing and re-adding some of the menu bars. So under virtualization, which is the thing we really want to go into today, under the overview, you've got this really nice, handy. I mean, it's just really helpful for debugging. So you can see top talkers, essentially, by memory, by swap traffic, by IOPS, by whatever you want it to be, write latency, read latency. We're getting good latency. CPU weight, really handy, ridiculously handy. I mean, how often do you kind of look at the system and go, which one's busy? Immediately you can see that, which is really nice. Under settings, we can do things like mess around with the amount of migrations, max migrations. We can also change the migration network if you want to dedicate it to a different VLAN. So all kind of relatively straightforward settings. You can configure the high availability stuff, which we'll get onto on the next. We'll get onto in a bit. I won't go into it now. One of the things I have enabled, going to virtual machines, is the ability to add folders, which none of the other products can do. Apart from, no, actually none of the other. Hyper-V can't do it. Proxmox, can Proxmox do it? It might be able to do it. VME can't do it. Very simple feature, but my God, is it helpful. You can see here I've got a bunch of virtual machines in different tenants, or different projects. Yeah, so what do I want to do? Probably just let's do a edit of a VM. So here's a 2025 VM. In fact, I'm not gonna pick that one because I need that one for something else in a minute. You got similar to the other technologies we've been demoing. You've got a pretty standard looking interface. You can open up the web console in a separate screen if you want. I don't think I want to, but you can do that. There you go. I'll close that down. You can log in, send, normal stuff. If you want to play around with the hardware, you go into configuration and you can change the memory type. You can see there you got GPUs, storage. I'm going to go and say, I need more storage. I don't know. I need 140 gig. I've changed my storage. That's now immediately going to go and talk. Actually, we'll talk to the NetApp as well. But it's also going to increase the disk on here. You can see I've never logged into this machine. I should have some additional storage now. Empty, you know how it goes. Yay, typical Windows 2025, stupid thing, stupid recovery partition in the middle. I'm not going to go into this part and delete that, but yeah, anyway, you can see I've expanded it and I can see the disk. That's all good. So yeah, basic stuff like that. It's a bit challenging in other areas. I think they need to do a bit of work. So if I was to change, I'm currently on pod networking, which if I show you what that looks like, break my I've picked a really bad image. Oh well, never mind. That's basically running on a 192. See if I can do it this way. I haven't done that in a while. 10022. If I went back to my slide, 10022. Oops, sorry, 10022. Every single VM is going to get 10022. Beneath that, it's got another network. So 10021 is actually a pod, which then routes back onto the network. So using pod networking, if I was to add this to Active Directory server and join it, it would DNS register with the same IP address as every other virtual machine. So don't use just don't use pod networking when you're using VMs because you're going to have a nightmare. If you didn't need any domain join and it was just a VM with some software on it and it was workload or whatever work group, then fine. But not a good idea otherwise. I do have some that are running in VLANs. So this guy should be running in a VLAN, and I can actually get to command prompt on him. So he's actually on my real network. So 10.254.11 is VLAN 11 in our network, and it's totally legitimately bridged. And you can do that with trunk ports and lots of VLANs, right? So that is the recommendation. The overlay network, I don't think I've actually configured it, but I mentioned it before with the on the other slide. If we go back to that slide, the overlay network is not routable at all. So it's just a private network essentially. So I'd have to, there's no IPAM, there's nothing on it. So I would have to manually put an IP address on it, on that particular NIC. I'm not going to do that now because you've probably got better things to see. But yes, if I did that, I could then talk to another VM anywhere in the cluster, as long as I've added an IP in the same CEDA on the same network, and it would work, and it would encap and de-encap happily. That's its UEFI screen, by the way. They haven't quite given it a nice logo yet. Yeah, it's going to boot because I've just finished it. So if you want to create a virtual machine, if I do one in here, this is where it gets quite nice. So create a virtual machine. I've got this concept of template catalogs or instance types. So these I've pre-put in. So I've pre-added, for example, a sysprept 2025 image. Let's say I'll pick that one. And then get a kind of cloudy-like experience where I could ignore it It'll let me. Go away. Hang on. I click user provided. I haven't got any because I haven't created any. But yeah, essentially I'm picking from types, and you can create as many types as you like. To be fair, HP, VME does the same thing. And I can put in a name. It puts random words in. I'll leave it like that. Why not? I can put it in a folder, give it some disk, tell it which storage class to go on. So which, that could be multiple arrays, whatever. I do get syspreps, so I can actually create an auto and attend and an attend and do automatic syspreps, which is really nice, just completely baked into the product, just like it is in VMware with guest customizations. And if I click create, it's going to go, and on the NetApp, it's going to create a flex clone of the template and spin it up fast. So obviously that is storage dependent. Depending on what storage vendor you are, it will do it in different ways. On the NetApp, it's doing space efficient flex clones. Within the backend config here on the NetApp, it's actually told to split on clone no, because it's commented out. So at the moment, the flex clone will be there forever. With the VM, it's just cloned. If you know NetApp, if I took that off at the end of the clone operation, once the VM's booted, it would then split it into a dedicated volume that's not dependent upon the source. But yeah, there you go. It's already done it. It's about to turn it on, and I have a Windows VM booting essentially. So yeah, quite nice console in terms of virtual machines. Quite nice. I like the way you've got the templates. If you do a Linuxy type machine, all of these ones are baked in. I didn't actually add these. These auto add. As soon as you add a storage class, they automatically build. So I went Red Hat 10. I do have additional abilities in here. So I can automatically add a SSH key for SSH key authorization. And I can also do whatever I like in Cloud Init. And if you've ever used Cloud Init, you can do a lot. So you can completely configure the virtual machine on boot in exactly the way you want. Cloud Init is how all the public cloud providers, if you don't use it in your organization, which you may already, all the public cloud providers leverage Cloud Init to do all the customizations on boot of virtual machines. There's documentation on it within the Cloud Init portal, and it's nuts. You can do anything. You can literally do anything. So you can fully customize the VM on boot, which is quite nice. These can be written into templates. So the virtual machine can become a virtual machine template, which you could put in common things you want to do. And then they can be cloned out with the things that are important to you baked in, which is quite nice. Yeah, so moving on, high availability is probably the next thing to talk about. So HA depends on the role. So if I go to here, node. So I've got these three guys running control plane and master. What that means is in the background, they're running a set of services, and one of those services is called ECT or ETCD, even ETCD, etc. D. And that is a key value pair data store database, which has a quorum model. And the reason why you have three nodes is because each node would have 33.333% of votes, same as all the other technologies we've been looking at, the kind of vote model, the majority vote model. And we need these to stay online with, so I can shut down master 2 and I've still got 66% of votes. But if I shut down both of those, ETCD would fail and the cluster would become unavailable. It'd become unreadable. So you want to kind of place these three in a good place. You can. They kind of don't recommend it, but you can have 3 physical sites or 3 aisles or 3, maybe not 3. I'm not really into rack awareness, but you could do rack awareness, or you could do floors or something within a colo. You could also do geographies. if you want it to. You have to be under 33 milliseconds of latency, ideally, and no more than 66. So it's not too bad. It's not like 0. It's not like 3 milliseconds. It's 33 is pretty easy to achieve. If you did 3 sites, you put 1 in each site. You could put 2 in each site if you want to do some resiliency for maintenance and failover, but really 1 in each site. The recommendation is rather than 3 is 4. The reason why is if you did maintenance on this one, and while they were doing maintenance on that one died, you'd lose quorum. So although 3 is the minimum, 4 is better from an availability point of view. etcd itself, heartbeats between these three control plane nodes heartbeat every 100 milliseconds, and they elect a leader essentially. And if they can't elect a leader after 1 second, there's a timeout, and another leader is elected. The etcd data store is fairly IOPS heavy. So when you deploy the nodes, if you deploy them through the new cloud console, then, which I guess I could show you, it'll take me a while to log in. Maybe I'll show you in a bit. Then it will do a performance check. It will do like a qualification check on your hardware, which is quite nice. Some of the UPI, the kind of granular manual installations don't do that, which may be a benefit if it's a lab and you're kind of trying to trick the system. We have boot from Fibre Channel, and we've got the NetApp array, so the actual boot LUNs are on the NetApp and they're spanned across loads of disks, so we have no problem. But if you don't meet 300 IOPS as a requirement, then the installation will fail if you do the cloud deployment. Yeah, so obviously within your nodes, if you think about designing them, you'd want a RAID 1 NVMe or SSD, or if it's HP server, you get those boot devices which have 2 M2 slots in them, that kind of thing. Other than that, all the other nodes are if we had them, we haven't got them. But if we had infra nodes and the worker nodes, they're stateless. There's no storage directly on them at all that you care about. The only storage you care about is the master nodes and the local etcd. But obviously, if we lost one, we could rebuild it from the other 2. So yeah, it's pretty good. One thing that's interesting is under machine. Interesting, I can't see it. Why can't I see it? I'm in virtualization. Node health checks. So out the box, just FYI, maybe write it down because it's a nightmare. It doesn't do fencing. So remember the node isolation thing, host isolation responses within VMware, those kind of things, like I'm down, but am I really down kind of question that the system has to ask itself is that node really down? And it has to go through a process of identifying whether it is or isn't down properly before it evicts it and unlocks the resources and the disk locks and that kind of stuff. That is not enabled by default on OCP. There are 3 pathways to configure it. This is one of them. This is called self-node remediation. It's almost identical to Proxmox. So it uses a softdog kernel module. It's almost identical. There are other fencing modes. One uses the IPMI, ILO, out-of-band networking to determine whether it is or isn't fenced. And there's another one which uses the bare metal provisioning machine config, this thing here, and it will detect that the node has failed through a mechanism and then actually delete. It will literally just go, I mean, I'm going to do it. I'm not actually going to do it, but it will delete the node that's failed, which then releases the lock on the objects and then allows them to be rebooted. So if it was virtual machines, it allowed the machines to be rebooted. If that node then came back, let's say it was temporary, came back, it would boot. It would boot up and it would re-enter the cluster automatically with no nodes on it, and that would all get sorted out. So there are 3 fencing options, but the point really is they're not there by default. So it's worth knowing that you need to configure them. Infrastructure nodes I've mentioned, I haven't got any in here. But yeah, not licensed, and B, just reduces the load on the control planes. because you can basically, if you put infra-nodes in, the control planes are just doing etcd. So you're creating that kind of, you're talking big, maybe 1,000, maybe more, 5,000 VM, like a very large environment. You might want to scale it out in that way. Again, you're not paying licenses here, you're just paying hardware. And DL36080, whatever, for Gen 10. So it's slightly, I'd say, older hardware to what's qualified with later VMware technology. But yeah, there's obviously the administration and the kind of operational overhead of having more stuff. But yeah, if you're going to design it to scale out properly and have real big infrastructure, then you'd kind of want to separate these things out. When you get onto the infra and the worker nodes, there is no quorum model. There's essentially a piece of software on the worker node called kubelet, which is an agent that runs on the node and talks to the control plane nodes and kind of says, hey, have you got anything for me to do? What's going on? So I could say, I want to schedule a virtual machine. Kubelet will go and check in with the control plane node, and together they'll work out where, I'll go into that in a minute, where and how it gets scheduled. But ultimately, between kubelet and the scheduling process within Kubernetes, that manages the HA. So one thing that's unique, I guess, to Kubernetes over other platforms is that the VMs themselves, the way Kubernetes works is it tries to keep everything in the state you've configured it for. So if I've configured this to be on, it will keep it on. Have a look at another one that hasn't got an error on it. It will try and keep it on. So if I went into this VM and shut it down, the control plane will turn it back on. So if I don't want that to happen, I have to go in scheduling and I have to deschedule it. So it's a slightly different paradigm. Kubernetes is trying to keep things up and running ultimately, and it will try its damn hardest. It will restart things. It will try and keep things online. But yeah, there is no quorum model. There's just that node's dead. Let's reschedule it over here. If it was a VM, it would just live migrate it. It's actually in the options. I think if I go into there, I'm going to find one. Pretty sure. Yeah, there you go. Eviction strategy. Live migrate rather than turn it off and restart it. How containers work is containers are, even when they've got persistent storage, that persistent storage is external to the container. So you can delete and restart the container and it will reattach to the storage. And normally with containers, you have lots and lots of them across lots of nodes, and then they're load balanced to each of the nodes. So you've got this kind of natural load balancing paradigm or pattern. And if you lose a node and you lose one object, one pod, it doesn't matter because you've got all these other ones up, essentially. So it will restart the container and it won't massively affect the application because there's all these other options. So that's how Kubernetes works generally, and Kubelet, which is the orchestrator for KVM on OpenShift, is kind of doing the same thing, other than you can got this special tick box, which will, rather than kill it and then restart it, will just live migrate it. So from a kind of high availability point of view, I guess what we could do, I want to have a look, see which node is less. I'm going to turn a node off. Let's see if I've got one. This guy here. Let's grab this guy because he's got an IP I can ping. Or can't ping. Why can't I ping you? You know why? Firewall. Bet your bottom dollar. It's a brand new build of 2025. So I bet you the firewall is on. That there. Oh, come here. I'll just turn it off. Yeah, turn the firewall off. So that is running on, where are you? You're running on node 0, so worker 0. Okay, so I'm going to go, like I did in the last ones, I'm going to go to my UCS, and I'm going to kill worker 0 and do this. I've got a better idea than the last webinars. What I'm also going to do is start this. So work, let me just remember that, short-term memory, worker 0, worker 0. That's an annoying thing in my UCS platform. Hang on. Thinks I'm already logged on, I'm not. Come on. Come on. There we go. Right. So I believe worker 0 will be that one. Worker 0. Right, I'm going to turn him off. Let me get these. I'll bring them back on the screen in a minute. Let's go move them there. Worker 0. Shut down non-gracefully. Bring him here. Bring him here. Start clock. So he's dead. So first thing that's going to happen is the state is going to be changed. Let me move these slightly out of the way. There's a timer. Health check for worker. Okay, yeah. That's sometimes typical. Yeah, it's kicked me out. It's fair enough. Might wobble a bit. Some of the components might have been running on that node. It's just healing itself. Oops. Wait for it to heal. Okay, pull me back. Oh, here you go. So not ready. This timer's 120 seconds. That's not default. Default's 305 minutes. Compute node. Not ready. So right now, while it's not ready, if I went into... So, okay, yeah, so you can see I've lost the virtualization section there. There's some of the components for that are running on that node and it's just restarting them. Kubernetes will self-heal itself. That will not affect the running of the virtual machines. That's just purely the web interface interaction is just restarting, which is why I got kicked out. It's not service, not service. I just want to reiterate that it's not service affecting. So you can see here, my console plugins are inaccessible right now. They will come back. Wait for them to come back. So what I need to happen is for this to be marked as non-schedulable or unschedulable through the node health check. This is the fencing configuration. Until that happens, the VMs, while it's fighting around with the console, I could probably show you one here. Yeah, so mine was, I think it was this one. So it still says running. Let's put it that way, it still thinks it's running on that worker node. So it's, in other words, the disk and all the VM and the objects are locked because it's not decided that it's isolated. It's truly isolated, should we say. It's still trying to work it out. So let it be for a minute. I want my console to come back first. Come on, console. Try log out, log in, see if it makes a difference. It's restarting pods in the background. Again, not service affecting, but it's just doing that. It's just GUI affecting, as it were. All don't have my plugins. Let's see how it's getting on. There's an events thing in here. I think it was in demo B, I think. Actually, can't remember which project it was in. These are all things that are going on in the background. Still not done it. So 6 minutes in, it's not done it. Slightly worrying. Oh, there we go. It kicked out again. Might have re-enabled the console. We'll see. Yes, it's re-enabled the console. Let's restart those pods. Where is it? There. Yeah, it's re-enabled them. Okay, fine. So I can go and look at my VM now. My VM should still be running on the dead node. I think it was that one. Worker 0, yeah, that's the one. So it's still got a lock on the VM at the moment because the fencing agent hasn't sorted it out yet. I don't want you to be sitting around here waiting forever. I'm gonna force it just to show you. Bye bye. So give it some time. It will realize that that node is gone. I just did that to speed it up. 7 minutes is quite long to sit around and watch it. Still see it's on working 0. It will sort it out. I've done it many, many, many times. I think 9 minutes was the most I waited. So I could come back to it. It's very boring watching it. Let's talk about resource scheduling while that's flying around. In fact, it's just done it. It's just done it. Look, node 0 starting. Yeah, it's reprovisioning, I think. Worker 1 console starting. That'll come back in a bit. So in that demo, my node health check. So this is my fencing configuration. Either took too long, I was too impatient, or it took too long. Both. There you go, it's back. Here we go. We're back, we're running. 8 minutes in, but I forced it. So you can see it takes a while. It's a lot longer than Hyper-V, and I think that's a lot longer. Yes, it's longer than the other two. It is tweakable. You can tweak it in here. But anyway, it's recovered it. There you go. There's for live demos. I have to go and look at my fencing configuration and see why that didn't kick in. It did in my prior attempts. So that's how that works. Resource scheduling. So I've said before, the VM will always stay up. So if I go and shut, I mean, whether it's worth me doing that, I don't know. Let me go and show you. I type my password. Let's kill him. Let's say I'm an admin of a VM. Ooh. Yeah, of course he crashed because I turned you off. I turn him off. Kubernetes is configured for it to run. So it's kind of, you've had a problem. It assumes there's been a problem. So it will then restart it. That's quite different. To change it, as I said before, you go into here and you mess around with the descheduler. There you go, it's already restarting it. So it's just worth knowing that. So Kubernetes itself has a project called KubeVirt. I have a slide on it, but it's complex, and I don't know whether I don't know whether you want to be confused. But yeah, like note in the webinar chat if you really want to see this slide, and I can explain the interconnectedness of KubeVirt. But essentially, what it is some software running in OpenShift, which talks to the management components of KVM, which talk to the kernel hypervisor in order to start the virtual machine, essentially. So there's a few interacting components within Kubernetes to ultimately, like an API and a controller, to ultimately orchestrate the booting of the KVM and the virtualization of the virtual machine through the KVM kernel. So KubeVirt is, you can go and research it, KubeVirt. That is the thing that makes this work, and it is it is how you can run a virtual machine in a containerized, in quotes, environment. It is not literally a container. It is a true KVM virtual machine, but it is orchestrated through things like a pod, which is more akin to Kubernetes. Do shout out if you want to see it. Just very quickly, some of the components, just so you can get a sense of it. Some of the components that relate to a virtual machine. So there's a virtual machine instance. There's a launcher. The launcher is what's interacts between Kubernetes and the KVM kernel to boot the VM. And there's a virtual machine object and some data volumes and some other bits and pieces, but these are all objects in Kubernetes which allow that virtual machine to start. Yeah. So scheduling wise, so when I turn this off and on, how does it pick? I mean, I've got in my compute here, I've got, I haven't, because I haven't turned it back on. I've only got one node, haven't I? Let me turn it back on. That's hilarious. Turn it back on. Poor node. I left him alone, turned off. Make sure he's booting before I. That's where I click that. Yep. He's going to come back and he'll re-register as worker 2. How does Kubernetes pick, whether it's a container or a virtual machine, doesn't really matter. How does it pick which node to go on? Well, there's a bunch of logic. I haven't got a slide for it, so I'm going to do it conceptually. Hopefully you'll grasp it. So the first step is it uses a filtering step to work out which node is feasible. So there are attributes, which we'll get into in a minute, which you can set on a virtual machine to say this VM must run on this node because this node has an NVIDIA GPU, or this VM must run in this zone. You can use cloud zoning like rack awareness or site awareness and say this one must run in this zone, that one must run in that zone, and that one in that zone. So using those mechanisms, it kind of says, well, which nodes are viable. It then checks whether the VM can run. So within the virtual machine spec itself, if I go and look at it, I see it from here. I don't know if I can see it from here. See it from here for sure. There are requests. Where are you? Well, you know what? I think it's on. I go to here. On this guy. They're there, but they're the wrong ones. So it is on that. So that's an example, but that's not what I want to show you. So basically, the spec of the virtual machine, the memory, and a portion of CPU is set in what's called a request value within the YAML file. So let me search for it because oh, there you go. You got it for storage. Interesting, I only have it for that one. Interesting. So there's normally a resource request size for the memory. I've seemed to have lost it. It's going to drive me mad. I don't like that. I don't like it when I can't find it. Let me see if I can look at another one. I swear it's in here. Go on, you can find it. $15 meg. It's these here, limits requests. Let me search for requests. That looks too small. There it is. Request. So 200 millicores. That means 0.2% of a core. So not a lot. It's requesting. Requesting means in order for me to schedule it, the host, the node, out of the ones it's already pre-filtered, the ones it's selected that it could run on, needs to have at least 0.2% of a core within the system, within the CPU available. And it needs to have, what's that, like I'm just going to say 4 gig, it's a bit more, 4 gig and 50 meg of storage. So it uses those request values to then create an algorithm or a maths equation to say, well, this node has this much free and I need this much, I need to request this much, etc., etc., etc. It goes through that process and scores the nodes. So the higher the score, the more preferred it is. And ultimately, it then uses the ranking of the scores and says, you're the best node. So out the box, it will 100% pick the best node, is the short answer. The best node based on whatever resources are available on the nodes. That's exactly how it does it. You can play with that. You can change the requests and you can make them larger, but ultimately it's picking them from the amount of virtual machine memory I've put in there. If it was a database and needed more CPU, you could go and modify that and say, I need 4 physical cores rather than 0.2% of a core. In addition to that, within Kubernetes itself, which applies to these virtual machines, because this is running in a Kubernetes environment, you have about 6 or 7 different logical mechanisms in order to schedule. There are lots of them. You have one called priority classes, which basically ensures that a virtual machine has more of a priority to run like a quality of service type over this virtual machine. And it's kind of a soft mechanism. So it's like you need to run before that one, or if you're trying to schedule both, this one wins. You have a preemptive class where you can say this VM has to schedule over this one. And you can even do it in such a way that if there's nowhere else for that VM to go, let's say the cluster's full and there's just one node, or let's say the selectors are such that it can only go to that one node and that node has this VM on it already, it will evict that node and put the VM in place. It's like a hard enforced priority class. There's a node pressure eviction. So the nodes are constantly being monitored for disk space, for memory, for inodes, basically compute resource. And you can get the node pressure eviction can move in a containerization world, just with pure containers, it would kill the container, bearing in mind there are many normally within a replica set. So killing one doesn't kill the traffic, it just kills part of it. And then they restart. Within the virtual machine world, it will live, because of the setting in the VM, it will live migrate it. So it will live migrate the nodes off to keep that node running. It's kind of relevant when you have this dedicated worker pool, but it's very, very relevant if you're sharing the control plane and the worker nodes together, because you really do not want to make that control plane node constrained of memory, because the thing will just crumble and fall over. Hence another reason you want to separate out those things. There's a thing called gang scheduling, which sounds bad, doesn't it? Gang scheduling. That's basically like, here's a bunch of VMs or a bunch of containers that absolutely under all conditions have to be scheduled together. And if they cannot be scheduled together, do not schedule them at all. So that'll be some sort of like distributed clustered system that, I mean, for example, like a dual phase commit SQL thing, synchronous write, these two have to be there together and have to be scheduled together. But potentially that's the use case. I'm sure there are many other, like maybe some Redis environment where you want them all to come together. You've got a concept of taints and tolerations. So taint is saying, I'm going to make my node, let's say my taint is red. I say it's a label you put on the node. So that node has a taint of red. Nothing will schedule on that node unless it has a toleration of red. So you're tolerating the taint essentially. So what you can do is make VMs go to a particular node or repel or not go on other nodes. So there's a way to it's that filtering mechanism to filter out what nodes are possible for that particular virtual machine. There's affinity and anti-affinity, like keep stuff together, keep stuff apart. That's really, it's way more complicated or way more sophisticated than all the other technologies. Maybe VMware gets close. So you can kind of say, I want this VM to be scheduled with that VM in relation to the rack awareness or in relation to site awareness. And you can build up quite complex and interesting logic to make things place in the way you want them to. I've done that a lot with other customers with Kubernetes platforms where they've had certain things happen which consume a lot of resource and they want that resource to be constrained at particular times, and you can kind of work it out through the logic. You've also got just a basic node selector thing, which I could probably show you very quickly, where you add a node you add a label to a node, and then you just select that within the virtual machine. It's actually within here. The tolerations are in here. So node selector here. At the moment I don't have a selector, so it's picked all 5 nodes. I can put a key value pair in, just a label, and then it would change that from 5 to 1. To do that, I would literally need to label the node, and I don't know whether I have any. Well, I have the label I want. So if I did OC label node, or let me do OC get node, OC label node. Let's label him, and let's put demo equals test. Demo test. Now I go back here and I say demo test. You can see I've only got 1 node matching, which is the node I just labeled. I really don't want that label. Let me just get rid of it. That's a way to basically, that's the filtering logic. So that's like taking away the possibilities of what node it can be scheduled on. In addition to that, you would then also still have the affinity and anti-affinity. Obviously wouldn't work with 1 node, but you get the point. Let me just get rid of that label. And I'm going to get rid of the label on that. I don't really want that label on it. Just do that. So yeah, anti-affinity and affinity, just so you can see it. I have some examples. Scheduling affinity. So this is an example of affinity. You can see this is now getting into code. It depends how you deployed this thing. You can just use the GUI. Like if you just want to be like a traditional infra guy and just use the GUI, use the GUI. You can edit everything, can play with everything in the GUI. If you're interested in IAC, infrastructure as code, then you would essentially bootstrap the cluster. Once the cluster is booted and started, the first thing you do is put in your CI/CD construct, which in Red Hat's world would be Argo CD. Argo CD would talk to a GitHub repo or as your DevOps repo or wherever your repos are, and it would look at that repo to decide what to deploy. You then go git commit, git add, git commit, git push, and you push to the branch into that Git repo, and then Argo CD would pull down and deploy it. So the point is you build up a repo which has everything in it, and you don't touch the cluster other than in the Git repo, which means if you needed to redeploy the cluster, you just redeploy a blank cluster, and then bush, out the box, it would just automatically configure itself exactly where it got to before. I'm sure you guys are aware of all this kind of stuff. Terraform is a classic example with public cloud. The point really is you can do all this stuff with OpenShift. It's baked into the product. So I would add this specification affinity, and you can see here, keep things together, prefer. So I'm saying basically if a pod has a pod, so when I'm saying pod, that would include the virtual machine as well, has app Fedora in it, keep them on the same host, wherever they happen to be scheduled. I haven't specified which node. Keep them together. That's it. If I had multiple of these rules, then there's a weighting system. And then anti-affinity is almost the same thing. It's the same file, but just different term at the top. So keep them apart. Yeah, that's it. So yeah, attach that to the virtual machine, which I can do through code, or I can just go and edit it. And it will move them around. So it goes in template spec. It would go here. I could put it in. Don't know whether I'm not going to do it, but that if you want me to do it, put it in the comments and I'll do it. But that is essentially how it works. Once you have that configured, you do have the option to do it in the GUI as well. I think there is anti-affinity rules here. So if you wanted to do it this way, preferred, required. So preferred is soft, required is hard. So basically, if I can't meet the requirement, don't turn the machine on. Put a weight in. Ooh, that's not numbers. What the hell? My keyboard is doing weird things, or my head is. And then host name, and add some key value pairs. It's basically what that is there, but I'm doing it in a GUI. So you can do it there as well. I think I did the taints and tolerations are in there too, which is there, tolerations. The taint is done on the node. It is worth knowing that a lot of these things, all of the affinity, anti-affinity, which you can see in the code actually, is it kind of, it's a giveaway. During scheduling, ignore during execution. So while it's on, not used, when it's been scheduled, do use it. So these things only apply at time of turning the machine on. They do not apply, they're not like DRS in VMware, where it's moving VMs around because the host is getting constrained. Kubernetes or Red Hat does that, but it does that through a different mechanism. That's the node pressure eviction mechanism. And that's more to do with if the node gets a bit too full. You could tweak that and say, I want to leave a larger percentage of resource free and do the node eviction earlier and then move VMs around. But yeah, it's on, power on is the point. So let me move on. What did we do before we? No, we finished that lab, didn't we? I just want to check. I want to check that my nodes are back. Yeah, you can see like I did delete this node because the isolation response or the fencing didn't kick in for some reason, and it's just come back. It's just booted and come back, which is cool. So the next thing to look at is live migration. So in a virtual machine, find a virtual machine. In fact, I'll do one that's on the proper network. Both the pod and overlay networks, I cannot ping directly using the default network settings. You can configure OpenShift to use custom container networking interfaces. They use OpenSwitch or OVN. Open Virtualization Networking, which uses Open vSwitch by default. That's their preferred choice. You can change that. You can use a different CNI. So you could use Calico. If you use Calico, you can do BGP, and then you can literally, these pod networks can be advertised into your underlay, into your core network. So you can actually reach the pod networking directly. Done it before for other customers. It's good. It's a good use case. Not always required. Out of the box in this environment, it's using the default SDN. There's no BGP. So these two, I can't ping them essentially from my physical underlay. If I wanted to reach them, I could advertise them through networking components, routes, ingresses, these kind of things. This would advertise these virtual machines over particular ports, but that's more to connect to it for a particular purpose. Let's say it's SQL or a web server or whatever it may be. It's not like broad full access to the virtual machine. It's very specific targeted things. Anyway, VLAN. I think my firewall should still be off. Yeah, there's my. I'm going to go and move him. So I get options, migration, I get storage migration option and compute option. So go compute. Hopefully it picks the node that it's not on. And I can move him. And all being good, he will move. We'll just wait for him. You shouldn't lose any pings. It uses contract and all the sexy stuff within the kernel to make sure you don't lose connectivity. He says, haha, here's a demo. And it's about to go, and it's gone. There you go. Done. Moved. No loss. Storage information is a bit more interesting. Like I say, this feature has gone in and out of the latest releases a number of times. So I'm not full of confidence here. But anyway, I'm going to move it. So you've got to bear in mind, it's worth recontextualizing what that means, because this is not traditional network storage. This is just totally not what you're it's not normal. It's unique to OpenShift or to Kubernetes itself. So I think I mentioned it before. So each of these storage elements is actually a real, in my array, it's a PVC. So if what is this pod network? Probably can find it. I can't remember how I labeled everything. And that's part of it. That's one of the disks. That's not the disk. I can't find it, but you can see Trojan. They are essentially flex files, individual flex files for each QCOW image. So when I want to move it, like what am I wanting to move? Like, because I can just move it. I can just go in here and move it. I can move it between an aggregate. I could move it between a node. I could, depending on your storage array, you can move stuff very easily, right? So do I need to move it in here or do I need to move it in here? Well, it kind of depends what I need to move, right? If I'm moving it between aggregates on a NetApp for performance or for space reasons, then I don't really have to move it in here. I could just move it in here. The reason why you'd use this is if I want to move it, for example, away from the NetApp. So I can go storage and I can move certain bits or other bits, but I'm going to move the whole VM. And then I can pick a new storage class. Now, I've only got a NetApp. So it's NetApp to NetApp to NetApp. If I had put in another storage array, I'd pick the other storage array and I would go next, next, next and finish. Now, the difference between these two is negligible. This one's enabled for SnapMirror, and that's for the next demo. This one is not enabled for SnapMirror. This one here is using, it's not using ONTAP Trident or NetApp Trident. It's using the native NFS CSI, and it's just got an NFS mount directly. I'll show you. It's always fun to see it for real. So let me just show you for real what that is. Through the magic of NetApp. I think it's that one. So this is where that storage class goes. And that is the disk. It's a raw file. It's interestingly, you probably remember, I don't really remember from the Proxmox world, when I was migrating, I could pick, in Proxmox, you can pick VMDK, QCOW, or RAW. This is a raw file. So that's my PVC, and that's my raw file. Interesting. Well, that's what it looks like. So I can move, I don't know where he is today. Let me just check. He's definitely not in there because the default one's there. So I'm going to go and move. I can't guarantee it's going to work. I'm going to give it a go anyway. Right, here you go. Boom. Let's see what happens. Like I say, this is come in and out of scope within the various recent editions of Red Hat OpenShift. So I'm expecting that to populate. I'm also expecting, I go storage migrations. There you go, it's doing stuff. I don't know if it's going to work. Ready. Migrating data may result in a failure, blah, blah, blah. Access, persistent volumes, pound pods. This is an intra-cluster migration plan. Intra, not inter. Yeah, that makes sense. And none of the source namespaces are mapped to different destinations. So this plan can only be used for storage conversion. Okay. Are you going to run? It says it's running. One volume, that's correct. Let's go and have a look on here. So what it does in the background is it copies. There are new features in Tech Preview at the moment with copy offload, so it can do a proper copy offload. But they're bleeding edge and they're not out fully. Right now, I believe it's going to copy it to a new PVC and then delete the old one, if it works. But essentially, that would allow you to move between storage arrays. If you're moving within the array, just move it in the array. If you did move it in the array, obviously the metadata, a bit like with KVM, you got the kind of metadata in the data concept. The metadata, so the PVC for, where was it? It was in demo B, I think. This metadata here for the volumes, I can't remember which one it was. I'll just edit this one randomly. So all of this stuff here, this is actually tied to the storage class, and the storage class is tied to the back end thing within Trident, which I showed you earlier. So it talks to the ONTAP CLI API. So if you did move it in the background here, just make sure you don't move it out of scope of the Trident backend, because that would probably break it, because the metadata would not reference a valid object anymore. Hopefully that makes sense. I don't know whether it is going or if it's failing. Running 0%. Oh, there you go. It's doing it. Where are we? We're not at 4:18 in the morning. I bloody hope we're not. The time's wrong on that clock. It started doing stuff. So we'll leave that going away. Ultimately, it's going to do what it said it would do. So next on the agenda is disaster recovery. How are we doing on time, Tom? We got about 20 minutes, 10 minutes? I'm going to go quick.
Yeah, we've got about 10 minutes, mate.
Okay, I'm going to go bloody quick. Right, so DR, what I'm going to do is I've got a secondary cluster. Secondary NetApp. And I'm going to move some workloads. So what I've done, I've prepared it. Thanks, let's log in. I'm going to move, let's say, demo tenant A is our source. And I have a secondary, this is second cluster, which is the smaller cluster. This just has a single node in it. And I'm going to untick that. I've got a namespace called demo tenant A. So I'm going to fail over these two VMs into here. So between sites. So it's doing that using SnapMirror. And it's using that Trident Protect and Trident itself. So Trident as a technology is an orchestrator for ONTAP API. So you can provision virtual machines and do stuff within the ONTAP world. Trident Protect is a backup product which backs up the metadata, the key value pairs out of etcd and puts them in an S3 bucket. Trident Protect will then replicate the S3 bucket with all the metadata to the second site so that it can be recovered. So similar to when I was doing the KVM failovers, you kind of got the data and then the metadata. Same thing here, you've got metadata, which actually lives in etcd on the control planes, which references the disks and the virtual machines and all the gubbins of what a virtual machine is. And then you've got SnapMirror, which contains the disks, those raw files that I was looking at earlier. So we need to link the two up. And to link the two up, the two products talk to each other to do that. So I'm going to bring up this. I've got a script I prepared earlier. A second. It's got a picture on it, which will help explain the scenario. Here we go. Bring this over here. So automated DR with OpenShift, Trident, and Trident Protect. So we have SnapMirror. These little blue boxes are just two NetApps. They're each of those boxes is in one HA pair. This isn't literally two separate NetApps. It's just a two node on site one, two node on site two. I've just put them separate because the top one is FlexVols and the bottom one is an S3 bucket. They happen to live in the same cluster, but I'll put them separate. So I'm going to run through this. I won't I'll bring that over there and I'll run through the script with you so you can see. The first thing I need to do is sign in to DC1 and DC2, which I have done. I need to be in that folder. Hang on, I need to be in the right folder. All right, while I'm in that folder, if I do OC project, and then OC, so OC is the command line tool for OpenShift. So I'm in the default project, so I need to be OC project demo tenant A. OC project demo tenant A. So I'm going to go into that project, and if I do OC get VM, I can see my VMs, OC get VM, no VMs. If I want to look at my backend config for Trident, you can see there I have backend configs. So top one is DC1, I mean it's bigger. Bottom one is DC2. You can see I've got backends for both individually. So one talks to one and two talks to two. I've got snap mirrors, so I should bring these up. So these are objects in Kubernetes, which then talk to Trident and Trident Protect, and through the API on the NetApp, establish snap mirrors and establish the bucket replication, all that kind of stuff. So this has already been set up in advance, but just so you can see it, I've got these are the storage classes. So these, as I said before, these talk to Trident. These are the persistent volumes. These are the Trident mirror relationships. So these are the actual snap mirrors in Kubernetes. On the bottom, you've got additional storage classes, and you've got persistent volumes over this side. But the ones over this side are actually DP volumes. So if you know NetApp, they are read-only because they are data protection volumes. And just looking at that, just want to make sure I'm in the right place. DC2, yeah, cool. And then these are the snap mirrors on that side. You can actually see the snap mirrors on both sides, but you can see this one is re-established and this one is promoted at the moment. Just want to make sure. DC1, right, I'm in the right place. I've also got an app vault. App vault. Oops. The app vault is the bucket. So app vault is a try and protect term for an S3 bucket on a NetApp. It's where it stores the metadata. On the bottom one, I've connected both because I won't do it today, but we can fail over and fail back, essentially. You can kind of, if you think of live recovery or SRM in VMware, you can fail over, reprotect, fail back, do the same thing. You can do many things within these technologies, this particular technology. You can do a redirected restore, a test restore, a full failover, a redirected full failover, a fail back. You can clone out to different projects just to do tests locally. There's like an insane amount of options as to what you can do. It's arguably more flexible than live recovery from VMware, but you don't get the GUI. That's the thing. You don't get the GUI. So next thing is to just fail over. So what I'm going to do, so let me just get my TMR, make sure it's there. Yeah. So TMR is my snap mirror, and I'm going to promote it. I do watch OC get TMR. Now promoting, so it's converting. If you're a NetApp person, and you understand it's converting the volumes from read-only DP volumes to RX read-write volumes. It's making writable basically, so I can then use them. So I've done the data. So the data is now live and writable on the target, but I haven't got the metadata. So to get the metadata, I need to do the app mirror promote, which I'll do now. I'm going to do watch that. That's now what that's doing is it's promoting the secondary bucket and restoring the metadata. So now do OC get VM. I've already got my VMs, they're starting up. So if I go back to my console in DC2, let's get rid of that. It's too many namespaces. Let's have a look at this guy. Yeah, he's turning on. There you go. I've just failed over from site 1 to site 2. Now, obviously, you do that from the recovery site. You do that from DC2. I've done it in such a way that I've actually technically done a test failover. So I've left the source VMs running just because it's a lab and I can do that. I could also do a full site failover. Like I say, you can do a redirected recovery. So I can say, I want to take the protected resources and store them into, let's call it redirected demo tenant A or something, so that if customers had running machines in these namespaces, these projects, I wouldn't affect them. It's very, very, very flexible. So that is the DR. The last thing, and I think we're running out of time, we've got 3 minutes. The last thing is migration. So I have had a lot of fun. Unfortunately, what I had to do fairly recently was rebuild our lab because I wanted to take the learning I'd had in the last sort of half year, whatever it has been, and sort of re-engineer the platform based on my new learning. And as I did that, I kind of broke migration, and I've not been able to I'm going to give it a go, right? So I'll show you. If it doesn't work, what we'll do is we'll spin up a separate video and slice it into the YouTube that will be posted on our website. So to do it, what you do is you install an operator called MTV, Migration for Virtualization, and that automatically connects to Red Hat. And then you add this additional, if I create a provider, I can migrate from OpenStack, I can convert an OVA, I can go from Red Hat Virtualization, I can go from VMware. If I edit this guy here, the one funky thing is you need to, I've put it on, I shouldn't do that because it's not, I've done it. You need to get the VDDK, a disk development kit from VMware and upload it onto a container registry. That's going to get deleted after this webinar because that's actually public and it shouldn't be published public because VMware don't want you to under their license agreement. But just to make it easy, that's what I did. It should technically, you should deploy a container registry, private one, or if you've got one private, and then deploy it into there. To do that, just very quickly, you follow the documentation, but you create a Docker image. So you create this Docker file, which copies the contents of the distribution kit into the container and puts it in opt. You then push it into your container registry, and then you can download it. And this accelerates, you don't have to do it, but this radically accelerates the migration process. One of the things you can also do, which is really good for if you compare it to the other technologies, I'm going to put demo, migrate to MCP. A lot of things have to be DNS compliant, so spaces and things don't work. I want to go from VMware to here on whatever the default network. So I get to pick my VM, which I think I've got a prepared one. So this one, what's he moaning about? You need to enable CBT, which I haven't done. Oh, I have done it. I know why it's moaning. Hang on 2 seconds. I'm going to log on to VMware. So you have to enable CBT, change block tracking. Should I quickly log in there? Changing that. I'll show you why it doesn't think it's on. Because it's off, you have to have it on. Oh. Edit him under advanced parameters. I'm going to copy the thing. Hang on. You have to enable these 2 flags. Well, that's obviously if ISCSI D00, you'd have to do it for the other ones as well if you had more. and then you turn it on, and you know it's on because it creates this file. Where's the VMDK? Why can't I see the VMDK? Oh, there it is. Okay, it hasn't. It should create a CTK file next to it. It's interesting, it hasn't. Let me go back to the console. Is it still moaning? No, it's not moaning anymore. Maybe I'm just blind. Anyway, you have to have it on in order for that to work. So you go next. You then, where do you want it? How do you want to map the network? Well, I want to map. It's on a management VM. I'm going to put it on VNet 11. Simple as. How do I want to map the storage? Well, it's on there, and I want to map it into one of my storage classes. It doesn't really matter. I'll put it in there. Now you get one migration, and it works. So one migration will take a snapshot, use CBT to replicate, and then it creates a cutover window, which you can then specify to do the last Delta sync, and then it shuts the VM down and turns it on in the new environment. So that's cool. That's very cool. Cold migrate obviously will shut the VM down and then migrate it. And we'll do warm. Lots of options in here. You can keep the same MAC addresses. You don't have to re-IP and that kind of stuff. Where do you want it? I want it on. And you can inject Ansible playbooks, both pre and post, which it runs on the disk image. And then I click create plan. It spins up some resources now. We're running out of time, so we're a bit over.
It's all good.
It's all good. There you go. Plan, go, bash, go. And you get a little thing here. You get this quite nice thing. I can't guarantee it's going to work because I had some issues with it, but I'm just going to show you. It will go. And if I logged into this, you can see it's already created a snapshot. Well, almost 100%. Which it uses for CBT stuff. Same way as Veeam does, and every man and his dog does that, right? Create a snapshot, remove the snapshot. That you love, 100%. Come on. We're in a hurry, mate. Come on. Once it's done that, it'll then go through and it'll mount the disk over the API and run a conversion tool, which converts it into a format inside the, here we go. So that must have finished. Yeah, Forklift is the name of the software. If I run this log thing, you can literally watch it. It's very boring. It'll go on forever, but it'll basically go and convert the disk. Disk, what, about 100? How big is this? 35. It's pretty small. So hopefully this will work this time. It's a very verbose log, which in some ways is good, I guess, if you have problems. It's launching containers inside the pods, and in order for it to do the conversions at this point. Eventually, it will get to the actual command it runs to convert the VMDK once it gets there. But that goes on and on and on. And ultimately, whether we want to sit there and watch it or not, it then goes into, if you look in the details, it'll then pause and ask to be cut over. And you can then schedule a time, which I think is that there, schedule cutover. So you can schedule when you want to do the final Delta sync cutover. And it'll boot the VM. It crafts a virtual machine object in Kubernetes, so it creates ultimately one of those guys, and spins it up. And the good thing is it does it hot, and it's fairly quick. Within overview settings, default is 20 migrations concurrently. So it's pretty good. You can increase these. These again are the limits. So limits, oh God, that's a Kubernetes concept we're not going to get into right now, but this limits on CPU basically constrain resource. So if it uses more than 2 CPUs on the host, then I can make it 8,000. It'll dynamically change that. That's 8 cores. And then memory limit. If the memory limit hits on a pod, it will crash. It does not do anything else. It crashes and restarts. So you obviously want this to be high enough. That's 8 gig-ish. So it's MI, so yeah, it's 8 gig. So you can make it as big as you need to. See, if you're doing migrations, you've probably got an empty infrastructure, so feel free to fill your boots with memory. And off it goes. Now, there is another product, which, as before, this is the last thing to talk about. NetApp Shift has the ability to talk to OCP. So you can, it has a magic ability, call it magic because it's very cool, to either do a traditional migration like we did with Prox and Hyper-V and VMware, or you can do an MTV plan. So MTV plan, can't do it right now because what it goes and does is it talks to Red Hat's MTV plugin, which we were just playing with. Let me bring it back. It talks to this plan. It goes and sucks them out of here and uses the information in here to then decide what to migrate in here. So that means you can pre-construct all of the information in the Red Hat portal, and then just do the quick migration in here. I have a problem with it, and something I need to address in NetApp directly, but I don't get any options. Oh no, I do, because I haven't got any. If I create another one, I go continue, I then get an error, and I can't get around the error right now. So we'll slice in a demo of this later, and I'll probably slice in another demo of this because look, this is just failed. So I have had problems with it since I rebuilt the cluster, I'm afraid. There you go. It's better to see it as it is and be real than cover it up and do all kind of marketing nonsense.
Yeah.
That's it.
Brilliant. No, thank you very much, mate. Thank you guys, obviously, for sticking with us there. As AC said, there are a few bits that we're going to try and get fixed in the background that will be recorded and then put into the final edited video. But we'll pop links out to all of you when that's done. But yeah, chat stays open. So if you have any questions in the meantime, just pop them across to us and we'll get them answered. But yeah, overall, thank you very much for joining us for the 4-part webinar series. It's been really good. Hope you found it useful. And the guys will be in touch with you to see how we can work with you in the future. If you've got any considerations moving to any of the technologies that we've shown, yeah, please get in touch and we'll put on a workshop. Thank you very much.
Thanks for your hand clap. See you later.
See you later.